Module 2, Lesson 5, we're connecting the visual models from Lesson 4 to the distributive property to find partial products of the standard algorithm. Let's look at the problem 21 times 5. In Lesson 4, we used a mental math strategy where we rewrote this in unit forms. We might have written this as 21 fives or 5 21s. 21 fives makes more sense because we can use some mental math with this. We can say 20 fives and then one more group of 5. Then we drew visual models to represent this. Well, these visual models are very similar to an area model. You know, if we counted the number of boxes, then we'd have the area of that space. Well, that is an area model. But instead of drawing each individual box, we just need to label the length and the width and know to multiply the lengths times the width. So in this case, I have 1 times 5, which gives me a partial product of 5 in that box. And then 20 times 5 would be the area of this space. And we can utilize the mental math strategies that we've previously learned to decompose 20 into 2 times 10. And then we can use the associative property to reorder that to be 2 times 5 and then multiply that by 10. So this becomes 10 times 10, which is 100. So we get a partial product of 100. And then 100 plus 5 gives us our product of 105. Let's look at 23 times 31. We can think of this as 31 23s. This is a concept that we learned in Lesson 4. When we think of it in this way, we can then see that we can do 30 23s plus one more group of 23. We're taking our 1 times 23 and then our 30 times 23, and we get 23 and 690 as our partial products. Then we're comparing that to the standard algorithm. When we're solving the standard algorithm, we'll first take our 1's place and multiply that by each number. So we'll take 1 times 3 gives me 3. 1 times 2 gives me 2. Then we are going to move on over to the 3, which happens to be in the 10's place. This is actually 30. To show this, we usually say put a 0 here as a placeholder since we're moving from the 1's to the 10's place. And then we can do 3 times 3, which is 9. But if you think about this, that 3 is in the 10's place, so that's actually 30. And 30 times 3 is 90. Then we move on to our next number, which is 3 times 2, which is 6. Again, I want you to think about this. That 6 is in the hundreds place. Well, I just took 30 times 20, and 30 times 20 is 600. So anyway, this gives us our partial products, and when we add, we get the same thing, 713. Go ahead and pause your video here and then hit play when you're ready to check your answer. We can think of 142 times 12 as 142 12s or 12 142s. Either is going to work, but if I went with 12 142s, I could think of it as 10 times 142 and then plus 2 more groups of 142. So let's go ahead and draw an area model that's going to represent that. Okay, 142 times 10 is really easy. Just add 1 0. Then 142 doubled is 284. Then I have these two partial products that I need to add together. And I get 1,704. Let's compare this now to the standard algorithm. All right, I'm going to take my 2 times 2 to get 4, 2 times 4 to get 8, and 2 times 1 to get 2. Now I'm moving over to my 1, which happens to be in my tens place, so that's actually 10. So we put a 0 here because we're doing 1 times 2, or technically that's 10 times 2, which is 20. Now 1 times 4 is 4, and 1 times 1 is 1. And I have another partial product, and we're going to add this together. And I get 1,704. And you'll also see that my partial products happen to be the same.